Continuation of our discussion about kinematics in one dimension, that is accelerated motion. Accelerated motion is the motion of an object said to be accelerated motion if its velocity changes with time. So an accelerated motion is a kind of non-uniform motion. So example of which is a vehicle moving on a crowded road. Like for example, you are riding in a vehicle, then you approach a crowded area. So tendency, your vehicle or the vehicle's movement is non-uniform. Sometimes it accelerates or it also slows down. So average acceleration, it is the ratio of total change in velocity to the total time taken which the change in velocity takes place. So that is average velocity is equivalent to total change in velocity over total time taken. Mathematical equation, that is the average velocity is equivalent to change in velocity over change of time. Take note that change in velocity is equivalent to final velocity minus initial velocity. So acceleration or instantaneous acceleration. This is the time rate of change of velocity at any instant of time. It's known as instantaneous acceleration or simply acceleration. So that is the acceleration is simply the derivative of velocity at any instant of time. So acceleration is also defined as the second time derivative of position, which is second derivative of position. And then acceleration is a vector quantity, so that can be positive, zero, or negative. When we see negative acceleration, that is this also known as retardation or deceleration. So deceleration and acceleration have opposite directions. So any vector quantity directed towards right will be taken as positive and directed towards left will be taken as negative. So going right is positive and taken negative, those are in the negative or the left side direction. So other types of acceleration, variable and uniform acceleration. So when we say variable acceleration, a particle is said to be moving with variable acceleration if its velocity changes equally in unequal intervals of time or unequally in equal intervals of time. And uniform acceleration, this is an object that is said to be moving with uniform acceleration if equal change in velocity takes place in equal intervals of time, however small these intervals may be. So generally, average velocity is equivalent to total displacement all over total time taken. Reminder, displacement is the shortest distance traveled of a body. But if the motion is uniformly accelerated, then the average velocity can also be written as initial velocity plus final velocity divided by 2. So taking its average velocity, this is when the motion is uniformly accelerated. So that is in mathematical equation, average velocity is v sub I, which represents initial velocity, and v sub f represents final velocity. So v sub I plus v sub f divided by 2. So this formula is only for constant acceleration only. So let's solve this illustration problem number 1.4. So a uniformly accelerated body, so that in a straight line has a velocity of 2 meters per second at any time. After some time, its velocity becomes 4 meters per second. Find the average velocity. So this falls under uniformly accelerated or constant acceleration. So the unknown is average velocity. So the given is initial velocity. So let's say given initial velocity v of I will be equal to 2 meter per second, and its final velocity is equivalent to 4 meter per second. Now average velocity, what is the formula for average velocity? Average velocity is equivalent to initial velocity plus final velocity over 2. So this will give you 2 plus 4 over 2. So the average velocity is 3 meter per second. So this will be the average velocity. So take note, these problems falls under uniform accelerated body or constant acceleration. So illustration 1.5. A car traveling at 20 meters per second takes a U-turn in 20 seconds without changing its speed. So what is the average acceleration of the car? So the question is average acceleration. Now let us draw the diagram. Let's say this is the uh, initial velocity of the car. Then it takes a U-turn without changing its speed. That is with the given time of 20 seconds. So time will be equal to 20 seconds. So let's say this is its initial velocity, which is v of I will be equal to 20 meter per second, and its direction, the direction of the car is towards right. So this is a positive value. Now taking the U-turn at 20 seconds, now the direction of the car is to the left, and it does not change its speed. So therefore, its final velocity is, will this be positive or negative? Recall sign convention, this is going towards left, so this is negative 20 meter per second. Point B. So sign convention, we call it sign convention. So this is final initial velocity is positive 20 meters per second, and then point B, this is towards left or negative direction. So this will become negative in value. So therefore, average acceleration. So average acceleration will be equal to average acceleration will be equal to change in velocity over change in time. So this will give you change in velocity is final velocity minus initial velocity over change in time. So this will become negative 20 meters per second minus initial, which is positive 20, so minus 20 all over 20 seconds. So this becomes negative 40 all over 20, so negative 2 meter per second squared. Take note that negative sign indicates the average acceleration is towards left during the time interval given. So this will be the final answer.